It's the first time humanity has encountered an interstellar visitor. Its astonishing speed and mysterious acceleration challenge existing knowledge. Is it alien technology or a natural miracle? It has no coma, but inexplicably accelerates, and its albedo is 10 times that of a typical asteroid or comet. A Harvard professor even proposed a guess that this thing might be a probe or light sail from an alien civilization. Its appearance instantly sparked debate among scientists worldwide. I will take you through a video to thoroughly understand the latest discoveries of Oumuamua and dissect its mysteries. October 19, 2017, Hawaii. The telescope at the Haleakala Observatory captured a fast-moving spot of light. Initially, no one cared much. After all, the solar system is not a system. Beyond hyperbelt, this reaches the solar system mass cloud. A highly favorable bodies on periphery of the solar system. These comets are occasionally subjected to the gravitational disturbances of passing stars, breaking away from their original orbits. Some plummet inward, becoming the long-period comets we can observe, while others may be completely ejected from the solar system, becoming interstellar wanderers. Similarly, other star systems in the universe may have similar comet reservoirs. Stars travel through the Milky Way, their gravitational fields interacting, and celestial bodies are constantly kicked out of their homes while others are captured by new systems. Scientists estimate that tens of thousands of such small celestial bodies may cross within Neptune's orbit every day. So when Oumuamua was first discovered, astronomers naturally assumed it was just another comet from afar and casually gave it a comet designation, see the 2017 U1. But soon a feeling of unease emerged. No matter how carefully astronomers observed, they could not find even a trace of the dust or gas that a comet should have around Oumuamua, which is what we commonly call a coma and tail. Comet black hole. This was too strange, so unprecedented. Oumuamua was stripped of its comet by an asteroid, A 2071. This was the first identity reversal in history of human astronomy, but that's not the end. Even greater shock was yet to come. When scientists accurately calculated its orbit, everyone gasped. Its speed was too fast. Open hyperbolic orbit, never to return. This irrefutably proved that Oumuamua was by no means a native of the solar system. It was a true extraterrestrial visitor. To commemorate this historic discovery, it was given the name a name full of Hawaiian flavor. Oumuamua thought it was the first distant messenger or scout. The International Astronomical Union also acted quickly and set up a brand new classification specifically for this type of celestial body, a representative of interstellar. Oumuamua became this new family's first member, number 1. In 2017, humans quietly opened a new page in their understanding of the universe, but no one expected that this surname would bring even more mysteries. Oumuamua's interstellar identity had just been confirmed when scientists discovered its strangeness far exceeded expectations. From morphology to movement, every feature was full of mysteries. Mystery 1, what does it look like? Oumuamua is very small, with an estimated length of 100 to 1,000 meters, but its shape is extremely strange. By analyzing the drastic changes in its brightness during a 7-hour rotation period, scientists speculated that it either looks like a stretched out cigar with a length to width ratio that could be as high as 10 to 1, or like an extremely flat pancake or frisbee. Whether cigar-shaped or disc-shaped, it far exceeds the common forms of natural celestial bodies. What's even stranger is that it doesn't seem to be rotating stably around its axis, but advancing clumsily and chaotically through space, like an out-of-control gyroscope. Mystery 2, its origin is a mystery. If it's like an asteroid, it's usually thought that asteroids fall near a star's habitable zone, then how is it so violently ejected across the endless sea of stars to reach us? Was it from a cataclysmic planetary collision, or from the garbage thrown out during a planetary system cleanup? If it is essentially still a comet, but its surface is covered with thick dust disguising its identity, then how long has it been wandering in the cold interstellar space? Millions of years or billions of years? Mystery 3, ghostly propulsion. This is the most core and puzzling mystery about Oumuamua. In 2017, September, it passed perihelion at an astonishing speed of 87 kilometers a second. According to the law of universal gravitation, as it moves away from the sun, its speed should gradually slow down. But the observation data showed that Oumuamua's deceleration was far less expected, as a small but persistent series force was deadly, pushing it from behind, counteracting some of the sun's gravity. dragging this non-gravitational acceleration. Although weak, about 17 meters per second when close to the Sun, it truly exists. And cannot be explained by pure gravity. Acceleration inevitably requires thrust. Where does this thrust come from? Mystery 4, abnormally bright. Initially, it was thought to be a dim rock. But subsequent infrared observations from devices such as the Spitzer Space Telescope brought unexpected findings. Oumuamua is unusually bright, with a reflectivity at least 10 times that of typical comets or asteroids in the solar system. This is more like it's the luster that only polished metal surfaces have. A shape that is strange, special, with an unknown origin, exceptionally bright, and accelerating on its own without any clear motive. All this combined makes Oumuamua so unique, even somewhat eerie. The scientific community was completely ignited, and various explanations and hypotheses began to clash fiercely. Facing Oumuamua's unexplainable acceleration, scientists racked their brains. Could it be solar winds and solar radiation pressure? Calculations showed that for an object the size of Oumuamua, these forces were too weak to produce the observed acceleration, so the most natural explanation would be cometary jets. But all observations showed it was clean, without any signs of gas or dust ejection. In the deadlock, the theoretical community gradually divided into two main camps, staging a wonderful scientific debate. Camp 1 challenge tradition and point directly to alien technology. The representative figure is Harvard University Professor A.V.I. Loeb. Professor Loeb's words were astonishing. He believes the most concise way to explain Oumuamua's behavior is to admit it is not a natural product. He calculated that if Oumuamua were an extremely thin object, its thickness might be only a few tenths of a millimeter, as thin as a piece of paper. Then the light pressure of sunlight would be enough to provide the observed internal weak acceleration, and such an extreme thin film structure is almost impossible to form in nature. Therefore, Loeb boldly speculated that Oumuamua is likely a light sail probe made by an alien civilization designed to use stellar light pressure to conduct interstellar travel, and we just happened to capture it passing through the solar system. This hypothesis is undoubtedly very impactful and quickly attracted the attention of global media and the public. The second sought new natural explanations. The representative figure is from Cornell University, Darryl Seligman, and others. Not all scientists agree with Loeb's alien theory. Seligman and others tried to find answers within the existing physical framework. They initially proposed a clear ice mountain model, assuming that Oumuamua is mainly composed of solid hydrogen. Hydrogen can only solidify at extremely low temperatures, and the gas produced during sublimation is hydrogen, which is transparent and invisible. This way, when Oumuamua approaches the sun and warms up, hydrogen sublimation can generate thrust, and we cannot observe anything. Sounds perfect, but Loeb quickly countered that solid hydrogen is too unstable. In long interstellar travel, even fake starlight would be enough to heat and evaporate, making it impossible to arrive at the solar system intact. Faced with strong battles, Seligman's team did not give up. They absorbed the criticisms and collaborated with Jennifer Bergner of the University of California to propose a more ingenious revised theory, the dark matter iceberg model. They believe that the core of Oumuamua may still be the familiar water ice, but during its formation and long interstellar journey, it may have adsorbed and locked a large number of hydrogen molecules like a sponge. This is possible in the laboratory and in theory. Cosmic rays and other radiation environments can also promote this process. When Oumuamua heats up as it approaches the sun, water, the crystal structure of the ice changes, slowly and steadily releasing these trapped, invisible hydrogen gases. This release process is gentle and hardly carries dust, yet it can produce enough thrust to explain that mysterious acceleration. Based on this, they proposed a new category of celestial bodies, dark comets. They pass. It generates a flyaway acceleration by releasing internally stored invisible gases, such as hydrogen. Therefore, there is no visible in the traditional sense. The scientific debate about the nature of Oumuamua is in full swing. Both sides insist on their own. Loeb believes that the dark comet model still has mathematical and physical doubts. Continue to promote his alien light sail theory. And just at this time, Seligman's team did something that turned the whole event around. They began to wonder if dark star. If the theory is correct, will this kind of celestial body that accelerates by releasing invisible gas not only exist in distant interstellar space, but also in our solar system? They carefully searched the existing asteroid observation data, focusing on those orbits. The anomaly seems to have a weak non-gravitational acceleration, but there is no celestial body with obvious eruption activity. As a result, they really found it. Not much, not less than 6 small forbidden areas, Small hearts perfectly meet these characteristics. The little hearts are very small and look unremarkable. Previously, their extremely weak acceleration had been regarded as an observation error or unresolved. The mystery is ignored. This discovery is of great significance, which means that similar to Oumuamua, that kind of invisible thrust phenomenon may not count special, it may even be happening around us. This undoubtedly provides strong indirect evidence for the dark comet theory. What is even more exciting? One of the 6 suspected dark comets, 1998 KY26, has already. It has been selected by the Japanese Hayabusa 2 probe as the next target. Hayabusa 2 completed the sampling and return mission of the asteroid Ryugu in 2020. Then embark. Chasing it, it is expected to be in 20. It will fly close to 1998 KY26 around 31. At that time, we will have the opportunity to unprecedented precision to directly test whether it exists gas release. To verify the dark star. Whether the model is valid, this exploration may become the key to solving the mystery of Oumuamua. A key step, although the exploration of 1998 KY26 it is exciting, but it is not Oumuamua after all. About this first. Many mysteries about the surname itself, especially its exact origin and composition, remain unsolved. Undecided, we only know that he comes from distant starry sky. Astronomers traced its trajectory and believed that it may have come from the direction of Lyra, and even locked several possible parent star candidates, but none could be confirmed, and now it's traveling at 26 kilometers per second. Speed towards deeper interstellar space, over 6 billion kilometers away, reaching the Voyager 1's photographed faint blue dot position, far beyond the reach of any telescope on Earth. Could these mysteries just disappear with Oumuamua's figure disappearing forever into the darkness? Some unwilling scientists have come up with an extremely bold idea. Send a probe to chase Oumuamua. This sounds like a scene from a science fiction novel, and the difficulty is conceivable. One is the speed. The speed gap. Oumuamua's speed is too fast, our existing rocket technology cannot directly catch up. The second is deceleration. Problem, even if you can catch up, how to accurately decelerate at high speed to achieve orbiting or even landing detection. It is also a huge technical challenge. Third, it's hard to lock in the vast universe to accurately locate and not autonomy target. There's only a few hundred meters long. The difficulty is no less than 5 needle in a haystack, although the challenge is huge. Also, didn't stop scientists' enthusiasm. The famous Project Lyra. Several complex chase schemes have been designed. The core idea of the plan is to use gravity to help push, like playing billiards, let the probe fly past the Earth, Venus, Jupiter, and even the Sun in turn. Use the gravity of these celestial bodies to accelerate or change orbit. One of the more feasible options is to launch a probe in the 2030s through a series of ingenious gravitational assist operations will eventually be carried out in 2048. About catching up with Oumuamua, mission designers believe that given Oumuamua's uniqueness and potential scientific value, such an interstellar chase mission will become a reality sooner or later. Of course, chasing Oumuamua is costly and risky. Do we have other options? Future astronomical observation technologies are developing rapidly. The Vera C. Rubin Observatory, which will soon be put into use, has unprecedented sky-seeking capabilities, expected to discover dozens or even hundreds of them every year. Interstellar objects similar to Oumuamua and can warn of their arrival months in advance than now, which will provides us with massive data for studying the entire interstellar visitor community. The ESA's Comet Interceptor mission is like a space catcher, planned to launch in 2029 and stand by in space. Once a suitable long-period comet is discovered, or a new interstellar object breaks in, it can set off quickly. Conduct close-range exploration. These future rockets will undoubtedly increase our understanding of interstellar celestial bodies, but they are powerless. Can replace Oumuamua itself. Body research. Each interstellar object will carry new information from time galaxy. And Oumuamua is made for the first one we've encountered whose behavior is so unusual, the secrets it contains maybe even more extraordinary. If we choose to wait for the next Oumuamua, we might have to wait. But the unique mystery about his first surname may really be missed forever. So what exactly is Oumuamua? A dark star with a hidden identity, a fragment of light left behind by an alien civilization, or a completely new celestial phenomenon beyond our current scientific understanding? To be honest, before we get more direct evidence, the scientific community cannot give a definite answer. The pursuit of the answer to the mystery is not only to satisfy curiosity, but also to understand. For the next messenger to arrive will be a great adventure about human wisdom and courage.